Here we have an example of a thin-walled open profile, and we're asked to calculate the second moment of inertia and section modulus for this shape. First thing which we want to do here is to first draw a diagram of this cross-section and draw there the imaginary center line. So let's do that first. So I'm gonna just freehand draw here. Like so. And now we're gonna draw the imaginary center lines. So first let's do it for the top half here. So the center line goes like that. Then for the bottom one. And finally the center one. Now we remember that the equation for the Ix is 1/3 multiplied by the sum of Si Ti power to 3, like that. Now let's call this one S1, S2, S3. So S1, the length of the S1 is just simply 160 millimeters. And the thickness of that section is 18. Like that. S2 is 250 millimeters plus 9 millimeters plus 11 millimeters. So 250 plus 20 millimeters. Okay, so it is 270 millimeters, and the T for that section T2 is 24, and then S3 is the entire width of the bottom section, which is 200 millimeters, 200 millimeters, and while the thickness of that section T3 is 22. And from this information we can finally calculate the Ix. Ix is 1/3 multiplied by the sum of 160 times 18 power to 3 plus 270 24 power to 3 plus 200 times 22 power to 3 millimeters power to 4, like so. And the value will be 2.27 times 10 to power 6 millimeter power to 4, like so. And in the case of open profiles, the way how we calculate the Wx is the dividing the Ix with the thickest part of the profile, and in this case divided with T max, so it will be 2.27 10 to power 6 millimeters squared divided by 24 millimeters. This section 3 is this middle section S2 is the thickest, being 24 millimeters, and the value for this one will be 94.6 10 to power 3 millimeters power to 3. And that's how we calculate the second moment of inertia and section modulus for open and thin-walled profiles.